Get ready to have your mind blown as we dive into 5 amazing facts about the universe. We're going to journey to the edge of black holes, witness the birth of stars, and even touch upon the mind-bending concept of time travel. All without ever leaving our seats. Let's explore the wonders of the cosmos. So buckle up, space cadets, and prepare for a cosmic journey that's both enlightening and funky. Let's kick things off by contemplating something so vast, so incredibly huge, that it makes Mount Everest look like a grain of sand. I'm talking, of course, about the universe itself. We often use the term astronomical to describe something enormous, but even that word falls short when describing the cosmos. Imagine this, our galaxy, the Milky Way, a swirling city of hundreds of billions of stars, is just one of trillions upon trillions of galaxies that make up the observable universe. And when I say observable, I mean the part of the universe whose light has had time to reach us since the Big Bang, roughly 13.8 billion years ago. That means the observable universe stretches over 93 billion light-years in diameter. Let that sink in for a moment, 93 billion light-years. To give you a sense of scale, 1 light-year is the distance light travels in a year, which is about 5.88 trillion miles. So 93 billion light-years, that's a number so large, it's practically incomprehensible to our human brains. And here's the kicker, that's just the observable universe. We have no idea how much more universe is out there. Beyond what we can see, it could be infinite. It's humbling, isn't it, to realize just how small we are in the grand scheme of things, but it's also incredibly exciting to think that we humans, these curious beings on a tiny planet orbiting an average star, have been able to unravel even a fraction of the universe's secrets. Is nothing short of astonishing. Now let's turn our attention to one of the most fascinating and mysterious objects in the universe, black holes. These cosmic monsters are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Imagine, if you will, the entire mass of our sun squeezed into an area the size of a small city. That's the kind of density we're talking about with a stellar mass black hole. But black holes aren't just cosmic gluttons, gobbling up everything in sight. They also play a crucial role in the evolution of galaxies. In fact, at the center of most, if not all, large galaxies, including our own Milky Way, lies a supermassive black hole, millions or even billions of times the mass of our Sun. These supermassive black holes act as gravitational anchors, holding galaxies together and influencing the orbits of stars and gas clouds around them. They're like the conductors of a cosmic orchestra, guiding the movements of celestial objects in a delicate gravitational ballet. And while we can't see black holes directly, since they don't emit light, we can observe their effects on their surroundings. As matter falls into a black hole, it spirals inward, forming a superheated disk of gas and dust called an accretion disk. This disk can glow brightly, emitting X-rays and other forms of radiation that we can detect here on Earth. From the darkness of black holes, let's shift our focus to the birthplace of stars' nebulae. These vast, colorful clouds of gas and dust are some of the most visually stunning objects in the universe. But they're more than just pretty pictures, they're stellar nurseries where new stars are born. Imagine a cloud of hydrogen gas, the most abundant element in the universe, drifting through space. Over millions of years, gravity draws these atoms closer together, causing the cloud to collapse in on itself. As the gas compresses, it heats up, eventually reaching temperatures high enough to ignite nuclear fusion, the process that powers stars. And just like that, a star is born, bathing the surrounding nebula in its brilliant light. Some of the most famous nebulae, like the Eagle Nebula and the Pillars of Creation, offer breathtaking glimpses into these cosmic maternity wards. But here's where things get even more interesting. The universe is a master recycler. When massive stars reach the end of their lives, they explode in spectacular supernovas, scattering the elements they forged in their cores, elements like carbon, oxygen and iron across vast distances. These elements then become the building blocks for new stars, planets and even life itself. That's right, the very atoms that make up your body were once forged in the heart of a dying star. We are, quite literally, stardust. Have you ever looked up at the stars and felt a sense of wonder about the vastness of space and time? Well, here's a mind-bending thought. When you look at the stars, you're actually looking back in time. How's that possible, you ask? It all comes down to the nature of light. Light travels at a finite speed, the fastest speed in the universe, but still finite. So when we look at distant objects, we're not seeing them as they are right now, but as they were when the light we're seeing left them. For example, the closest star to our sun, Proxima Centauri, is about 4.24 light years away. That means the light we see from Proxima Centauri today left the star 4.24 years ago. Now consider galaxies that are millions or even billions of light years away. When we observe these distant galaxies, we're seeing them as they were millions or billions of years in the past. It's like looking through a cosmic time machine, peering into the universe's distant past. So, the next time you gaze up at the night sky, remember that you're not just looking at points of light, but at snapshots of history, each star and galaxy a testament to the universe's long and fascinating story. For centuries, astronomers have studied the universe by observing light, but there's another way to explore the cosmos, by listening to its symphony of gravitational waves. These ripples in space-time are caused by some of the most violent events in the universe, such as the collisions of black holes and neutron stars. Imagine two black holes locked in a gravitational dance, spiraling closer and closer together until they finally collide and merge. This cataclysmic event sends out shockwaves, not of sound, but of gravity itself, that travel outward at the speed of light. These gravitational waves, first predicted by Albert Einstein over a century ago, were finally detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. This groundbreaking discovery opened up an entirely new window into the universe, allowing us to study objects and events that are invisible to traditional telescopes. It's like we've been watching a silent film of the universe for centuries, and now, for the first time, we can finally hear its soundtrack. And what a soundtrack it is. The collisions of black holes produce deep, bass-like rumbles, while the mergers of neutron stars create high-pitched chirps. By studying these gravitational waves, we can learn about the properties of black holes and neutron stars, test Einstein's theory of gravity in extreme environments, and even gain insights into the nature of gravity itself. Thanks for joining us on this cosmic journey. I hope you enjoyed grooving to these mind-blowing facts about the universe as much as I did. It's truly humbling and awe-inspiring to contemplate the vastness and wonder of the cosmos. Don't forget to like, subscribe, and hit the bell icon for more mind-blowing facts about the universe. And the next time you're feeling stressed about something here on Earth, take a moment to look up at the night sky and remember, we're all part of something much, much bigger than ourselves. Stay curious and keep looking up.